Meet Maya. She's a 7th grader who just got a challenge from her science teacher. Figure out how many students in her school of 800 kids prefer pizza over tacos without asking all 800 people. Maya stares at the assignment and thinks, that's impossible. But here's the secret. Mathematicians and scientists do this kind of thing every single day. It's called making inferences from data. And by the end of this video, Maya and you will know exactly how to do it. Before Maya can solve her challenge, she needs to know two very important words: population and sample. The population is the entire group you want to learn about. In Maya's case, that's all 800 students at her school. A sample is a smaller group you actually collect data from. Instead of asking 800 kids, Maya might ask just 40. The big idea is this: if your sample is chosen well, it can represent the whole population. Think of it like tasting one spoonful of soup to know if the whole pot needs more salt.
Here's where it gets really interesting. Not all samples are created equal. Maya could walk up to her 40 best friends and ask them, but that's a bad sample because her friend group might all love the same thing she does. A good sample has to be random, meaning every person in the population has an equal chance of being picked. It also needs to be large enough to be meaningful. A random sample of 40 out of 800 is about 5%. That's actually pretty solid for making a prediction. Let's see how Maya picks her sample the right way.
Okay, so Maya has her random sample of 40 students. Now what? She counts the results and looks for a pattern. That pattern from the sample is what she uses to make an inference about the whole population. An inference is an educated conclusion based on data. It's not a guess, it's a logical prediction backed by evidence. Here's the big 3-step process. Step 1, collect your random sample. Step 2, analyze the data from your sample. Step 3, scale up your results to the whole population. Simple, right? Let's watch Maya do it. Here's the math muscle we need: proportional reasoning. When Maya finds that 24 out of 40 students in her sample prefer pizza, she can write that as a ratio, 24 to 40. She can simplify that to 3 out of 5, or 60%. Now she scales up. If 60% of her sample prefers pizza, she predicts that 60% of all 800 students prefer pizza too. 60% of 800 is 480 students. So Maya's inference is about 480 students in the school prefer pizza over tacos. That's the power of proportional reasoning. Let's walk through Maya's full pizza problem together. Maya surveys 40 randomly chosen students. She finds that 24 prefer pizza and 16 prefer tacos. First, let's write the pizza ratio, 24 out of 40. To simplify, both 24 and 40 are divisible by 8. 24 divided by 8 equals 3, and 40 divided by 8 equals 5. So our simplified ratio is 3 out of 5. As a percent, 3 divided by 5 equals 0.60, which is 60%. Now we scale up. 60% of 800 equals 480. So Maya predicts about 480 students in the whole school prefer pizza. Great inference, Maya. Let's try another one. A school cafeteria surveys 50 randomly selected students to find out how many prefer salad for lunch. They find that 15 out of 50 students choose salad. First, let's write the ratio, 15 out of 50. Both are divisible by 5. 15 divided by 5 equals 3, and 50 divided by 5 equals 10. So the simplified ratio is 3 out of 10. As a percent, 3 divided by 10 equals 0.3, which is 30%. Now scale up to the school's 600 students. 30% of 600 equals 180. So about 180 students in the whole school prefer salad. The cafeteria now knows how much salad to prepare. Ready for the next level? A librarian surveys 40 randomly chosen students. She finds that 18 out of 40 students read fiction books. Let's find how many of the school's 560 students likely read fiction. Step 1. Write the ratio, 18 out of 40. Both 18 and 40 are divisible by 2. 18 divided by 2 equals 9, and 40 divided by 2 equals 20. Simplified ratio, 9 out of 20. As a percent, 9 divided by 20 equals 0.45, which is 45%. Now scale up. 45% of 560 equals 252. So the librarian infers that about 252 students in the school read fiction. Now she knows which books to stock up on.
Maya is getting really good at this, but let's pump the brakes for a second. Inferences aren't perfect, they're predictions, not guarantees. A few things can make your inference less accurate. First, a biased sample, like only asking athletes about their favorite sport. Second, a sample that's too small. Asking only 5 people out of 1,000 won't give you a reliable picture. Third, the sample needs to match your population. If your school is 50-50 boys and girls, your sample should reflect that too. But statisticians always think about whether their sample is truly representative.
Let's put it all together with one more challenge. A city park surveys 80 randomly chosen kids. They find that 56 out of 80 kids prefer basketball over soccer. The city has 1,200 kids total. How many prefer basketball? Step 1. Write the ratio. 56 out of 80. Both are divisible by 8. 56 divided by 8 equals 7, and 80 divided by 8 equals 10. Simplified, 7 out of 10. As a percent, 7 divided by 10 equals 0.70, which is 70%. Now scale up. 70% of 1,200 equals 840. So the city infers that about 840 kids prefer basketball. Time to build more basketball courts.
You might be thinking, okay, this is cool math, but who actually uses it in real life? The answer, pretty much everyone. Election pollsters survey a sample of voters to predict who will win an election. Netflix analyzes a sample of viewers to decide which new shows to create. Scientists survey samples of animals to estimate population sizes in the wild. Even your favorite sneaker company surveys a sample of customers to decide which shoe colors to make next. Every time you see a statistic on the news or in an ad, someone used a sample to make an inference about a larger population. That's the math you just learned.
Look at Maya now. She went from totally stumped to completely confident. Here's a quick practice problem to try on your own. A sample of 25 students shows that 10 out of 25 prefer reading over watching TV. The school has 500 students. How many likely prefer reading? Pause the video and try it. Here's the answer. 10 out of 25 simplifies to 2 out of 5, which is 40%. 40% of 500 equals 200. So about 200 students likely prefer reading. Did you get it? If you did, you're already thinking like a statistician. Parents, this is a fantastic one to work through together. Remember when Maya had no idea how to figure out 800 students' pizza preferences without asking everyone? Now she and you can do it like a pro. Here's what we covered. Population is the whole group. Sample is the smaller group you actually study. A good sample is random and large enough to be representative. To make an inference, find your sample ratio, convert it to a percent, and scale it up to the population. And remember, inferences are predictions based on evidence, so the better your sample, the better your inference. You just learned one of the most powerful tools in all of data science.